Malware, hackers, and data breaches. We hear about those things all the time, but very few of us actually get to see how those things work and what they do. And that's what you're going to see in this video. Hi, my name is Lior Malka and you're watching the channel Next Generation Cybersecurity. Today we're going to be talking about malware, but not just talking, we're going to see some real live examples that I recorded here on my computer. We're going to cover a wide array of terminology, starting with basic things like bugs and vulnerabilities, all the way to keyloggers, data breaches, ransomware, denial of service attacks, and so on. And all of these things will be with live examples that will help you build a mental map of all this terminology and how it works, so that when you go and read the news, you know what they're talking about. The thing that you're going to learn in this video will be useful for you with your home computer, with your phone, and even if you work for a tech company, it will be of immense value for you. One of the key tools I'll be using in this presentation is called Metasploit. However, this presentation is not about Metasploit. It's not about how to use Metasploit. It's not about how to create malware. It's all about educating you about how hackers work and how you can protect yourself. This presentation is not to encourage people to go and do illegal things. It's not to encourage people to go and break other people's computers. It's a presentation, again, to help you better protect yourself. And we will be looking at a lot of products and companies. And we're only going to use those companies and products as examples. We're not trying to make any company or product look bad. And I realize that most of you, after you're going to watch this video, will ask yourself, okay, so what can I do? So this advice is not in this video, but I'm definitely going to create another one. So please hit the subscribe and notify button. And I'm looking forward to making another video for you. The first video is going to be very basic. It's actually a program that I've created myself. It's called PIN. PIN because it asks you to enter a 4-digit PIN. And if the PIN is correct, it will display some secret. In this case, it's a Windows activation code. And if the PIN is incorrect, the program will simply say that the PIN is incorrect. It's a very simple program. It's not intended to be a secure program. It's just a program that we're going to be using for demo purposes. So let's run this program and see how it works. So as you can see, I have 3 versions of the PIN program. The first version is PIN 1. I'm going to run it now. As you can see, it's asking for a 4-digit PIN, and I'm typing the wrong PIN. The right PIN is 1234. Here you go, I'm typing the PIN, and as you can see, it displays my activation code for Windows. Again, this is not meant to be a secure program, it's just meant to be an example program. The second version of this program has a bug. As you can see, instead of terminating, it does not terminate, it runs in an infinite loop. It's not stuck and it didn't crash, it just runs in an infinite loop, and I need to hit Ctrl+C to break the application and get back to the command line. This behavior is considered a bug because it's not the intended behavior of the program. However, this bug does not degrade the level of security of the program. In other words, an attacker cannot take advantage of this bug to compromise the level of security that the program provides. Now we're going to run the third version of this program. This version does not have the bug that it does not terminate, but it has another bug, which is input validation. It does not check that the input from the user is of the correct length. As you can see, when the input is very long, the program terminates and it displays a message that says that there is a segmentation fault. Segmentation fault basically means that the program is trying to access memory locations that it's not supposed to. And when hackers see this message, this is a sign that the program might be vulnerable. In order to attack the program, we will need to input special characters that are not found on the keyboard. So what I've done is I created a file called pin.txt. This file contains the characters 1, 2, 3, 4, and as you can see, when I pipe the input from this file into the program, I don't need to type them on the keyboard. The application takes the input from the file and behaves as if it was typed on the keyboard. I'm going to use the ability of providing input through a file to give the program characters that are not found on the keyboard. And the next file that I'll be using is called input.bin. As you can see in this file, the input is very long. It's a sequence of A's followed by B's and C's and D's and E's and F, and finally there are two funky characters at the end. Those characters, again, cannot be typed on the keyboard. That's why I'm using input from a file. As you can see, I'm giving the program the input and I'm running the program. And when I do, I get the error message that the pin is invalid, but later I get the activation code. The program is not supposed to print the activation code unless you have the correct pin. In this case, I don't have the correct pin and I can still see the activation code. So this bug is a vulnerability. Let's look at what happens behind the scene when we run this pin 3 application. First thing, the program is loaded into the memory. The program has code and data. The code is in some memory location and the rest is for data. When the program starts, the operating system jumps into some place in the program and it comes from location X. The program needs to remember this location so that it can jump back to this location. So it stores this location X in the data area. Next, the program is trying to read the pin from the user. So it needs to allocate 4 memory cells for the pin. Because the program does not verify the length of the pin that the user inputs, the user can type a very long pin that, when stored in those memory cells, overflows and overwrites the return address X with some other value. We configured this value to be a very specific location Y, which is the location in the code of the display activation code function. When the program returns, instead of returning to location X, it returns to location Y, and that's why it shows that the pin is incorrect, and then it displays the activation code. Okay, so now that you know what is a bug and what's the difference between a bug and a vulnerability, let's proceed to the next important terminology, which is exploits and payloads. An exploit is a file or method for exploiting a vulnerability. There are local exploits and remote exploits. The exploit that we just saw was a local exploit. A payload is the part of the exploit that is actually doing the malicious activity. In our case, the exploit is the file that contains the long string of characters, and the payload is the address at the end of the file that the malware forces the application to jump to. Now, there are all kinds of vulnerabilities. The vulnerability that we saw just now is an arbitrary code execution vulnerability. It's very common and it's actually the most powerful vulnerability. It allows the attacker to execute code on your computer. In this case, I didn't really try to execute arbitrary code. I just wanted to execute a jump to a certain location. Sometimes the attacker cannot force an arbitrary code execution vulnerability, but they can do other things. For example, they can crash your device. On iPhone, there was a vulnerability that allowed attackers to send a message to a user, and this vulnerability was interactionless. The user didn't have to do anything. The vulnerability caused the iPhone to crash. Another vulnerability from last year, 2019, was a vulnerability with the iMessage application on all Apple devices, including laptops, phones, and even the Apple Watch. This vulnerability allowed an attacker to send a message to a user, an iMessage, and get back a piece of memory from the user's device. Again, this is an interactionless vulnerability, which means that the user does not even have to do anything to be impacted by the vulnerability. Something interesting about this vulnerability, it was discovered by Google Project Zero, and when I looked at their website, they said that the vulnerability can be combined with basic steps to actually create arbitrary code execution. On the Apple website, on the other hand, the vulnerability is only described as one that allows an attacker to access memory that they should not be able to access. So the conclusion from this is that when companies report vulnerabilities, they only focus on the nature of the vulnerability. They're not going to extrapolate or tell you about the wider impacts of the vulnerability. That's why you need to stay on top of the news and understand all the terminology that we're going to see in this video. The demos that I recorded for this presentation have been recorded on my desktop computer, and I want to show you what it looks like so that you don't get confused about the different parties in the attack. So as you can see, I have two virtual machines. They mimic two separate computers. One is the attacker computer, the attacker VM, and the other one is the victim VM. The victim is going to be running a Windows 7 virtual machine, and the attacker will be running an Ubuntu Linux virtual machine, and I'll be using Metasploit on the attacker VM to attack the user. The first demo that we're going to see will involve Internet Explorer. The attacker is going to create a malicious link and hope that the user is going to click on that link. Let's see how it works. This is the victim machine, and as you can see, there is a link that the attacker sent to the victim, and the victim is tricked into clicking on this link. And what I've done here is I took a snapshot from the Amazon website. It's basically just an image. It's not the real Amazon website. And behind the image, I put a link to the attacker computer. So this is what the HTML webpage looks like. As you can see, there is a link to the attacker machine, and the victim is going to click anywhere on the picture and going to get redirected to that link. When the victim clicks on the link, the malware triggers a vulnerability in Internet Explorer and causes arbitrary code execution. The attacker is just trying to execute something benign, which is to launch an application, in this case, the Paint application. Here is how things look like from the attacker's computer. The attacker configures the exploit. It's a payload that executes the Paint application. The attacker launches the exploit by typing exploit from Metasploit. The server starts. Once the user clicks on the image, the browser on the victim side requests the exploit from the attacker's VM, and the attacker sends the exploit, which then causes the vulnerability in the browser of the victim, which eventually causes the payload to execute. In this case, the payload simply launches Paint. The attack that we just saw with Internet Explorer is actually very similar to the attack that I showed you previously with my simple PIN application. In both cases, the attacker took advantage of an arbitrary code execution vulnerability to execute whatever they wanted. The difference is that in the PIN application, the exploit was local. The attacker had to be running locally to take advantage of this vulnerability, whereas here with Internet Explorer, the attacker can take advantage of the vulnerability remotely. So it's a remote code execution vulnerability. Now, the other thing that I want to point out is that to simplify the presentation, I just created a web page, and I put the link for the web page on the desktop of the victim. Of course, typically the victim would get the link in other means and then get tricked to click on the link. Phishing is one example that attackers use to trick users into clicking on links. Phishing is communication, typically via email, that appears legitimate but has malicious intent. Another example where users are tricked to click on malicious links is a Waterhole attack. A good example of a Waterhole attack is the Department of Labor website from 2013. Attackers hacked the website and placed a malicious link on the website. Visitors to the website did not suspect that the website may contain a malicious link, and anybody who clicked on that link and had the vulnerable version of Internet Explorer might have been affected. So far, we've seen two kinds of malware, but both of them executed something benign. Let's start to do some more serious stuff. In this case, I'm going to take advantage of the same vulnerability in Internet Explorer, and as you can see, when the victim clicks on the link, nothing happens on the victim side. But what actually happens on their computer is that malware is gaining control and creating a reverse connection to the attacker machine. The attacker is now controlling the victim's computer. Let's see what things look like on the attacker computer. The attacker is launching the exploit and waiting. The victim clicks on the link, as you can see at the bottom right corner. And once the victim is infected and a connection is created from the victim side to the attacker machine, the attacker can interact with a session on the victim's computer. The first thing the attacker does is to take a screenshot of the victim's computer. There you go. This is the screenshot from the victim's computer. The attacker identifies an interesting file on the desktop, so he can list all the files on the victim's computer, see this file, and then download it to the attacker's computer. The file has been downloaded. Let's open it. As you can see, it's a W2 Of course, this is all fake for the sake of the presentation. There are many things that the attacker can do. They can record the keystrokes, they can interact with the webcam, start it, record from the microphone, do all sorts of things, and we'll see some of those things later in the presentation. Once an attacker gains control of a victim's computer, they can turn this computer into a bot. Essentially, the bot is like a robot. It has some command and control software that connects to another server that the attacker controls, and the attacker can issue commands to all these bots to do all sorts of things like denial of service attacks, sending spam, all sorts of malicious activity. The ability of the attacker to steal files from the victim's computer may actually lead to far-reaching consequences. Here is why. When you browse the internet, when you log into a website, you get back a cookie. This cookie is a session cookie. It helps your browser prove that you have logged into the website. It allows your browser to interact with the website that you just logged into. Those cookies are stored on your hard drive. They are files. So if those cookies get stolen, an attacker can use them to log into your accounts. Let's see how it works with Gmail. I'm gonna try to log into my Gmail account. I have two-factor authentication, so I'm getting a code on my phone and I'm gonna type it back into the browser. There you go, I'm logged into my own personal Gmail account. Now what I'm gonna do is I'm gonna take the cookie file of my browser and I'm gonna copy it from its directory to my desktop just to show you the file. There is no reason really to do this copy operation. It's just to show you the cookie file. There you go, the file is on my desktop. Now we're looking at the attacker's computer, and of course you can see the cookie file. I just moved it into the attacker's desktop. No user is going to give their cookie file to some attacker, but in this case we already know how attackers can steal files, so to simplify the presentation I simply move the cookie file from the desktop of the victim to the desktop of the attacker. Let's see first that the attacker is not logged into Gmail. Okay, now let's copy the cookie file to its default directory. Now we're going to launch Firefox again, and as you can see, the attacker is logged in to my account just by stealing my cookie file. You can see my name and my email address. Another thing the attacker can do is leverage their access to my Gmail account in order to access my other accounts. For example, the attacker can go to LinkedIn and use my Gmail account to access LinkedIn. Another thing the attacker can do is go to some password manager and see if I have an account there. They can simply click on forgot my password, tap my email address and click on send hint. Because they have access to my email account, they can get the hint and then leverage that hint to access all of my passwords. Now, like I said in the beginning of this presentation, the point is not to say that Gmail is not secure or that LastPass is not secure. We're not trying to make any product look bad. This is just internet technology. That's how it works. If attackers get access to your computer, they can steal files, access your Gmail accounts, other accounts, and probably all of your passwords. Another takeaway from this demo is that multi-factor authentication may be useful, but it has limited ability to protect you. In all of the examples that we've seen so far, the attacker was using a vulnerability on the victim's computer in order to execute arbitrary code. However, hackers sometimes implant their malware in software that looks legitimate, and then they hope that the user will just download and execute this program. This kind of malware is called Trojan. A Trojan horse is a present that was given to the city of Troy. When the city took the present, soldiers came out of the horse and attacked the city. So a Trojan horse is a symbol of something that looks good on the outside but contains something bad on the inside. A good example for Trojan malware is the Angry Birds application. Hackers took this application, created a malicious version of this application and pushed it to the Android App Store. People think that the Apple Store is safer, but last year hackers were able to push Trojans into the Apple Store as well. Sometimes hackers break into the companies that make the products that you purchase. They're able to push their malware into the product even before it gets to you. In 2019, hackers broke into ASUS and were able to implant malware in the software updates that ASUS users automatically get into their computers. Now, those updates are typically signed with a special key that is secret, but the hackers were able to find the key, implant the malware in the updates, and then sign those updates with the secret key to make those updates legitimate. Any user that has an ASUS computer, their operating system would from time to time go and pull updates from the ASUS company. It would pull up those updates, check the signature key, see that the signature key is valid, and then install the update with the malware inside. So this example shows that even if you're careful about what you download and you only download from legitimate sources, you can still get Trojan malware in your computer. We're now moving on to the second part of the presentation, and here we're going to continue to exploit vulnerabilities, this time in Acrobat Reader, to attack a user who is in this case an employee of a company, and we're going to leverage our attack against that employee to access the company. So we're going to be focusing on data breaches, ransomware, and more corporate style attacks. Until now, we only saw two virtual machines, the attacker machine and the victim machine, but because we're going to show how data breaches work, we'll need the company's servers. So I added a third computer that I'm going to call just the server. So in this demo, the attacker will be creating a malicious PDF file and send it to the victim. The victim is an employee of a tech company. The victim will open the PDF file and will get infected with malware. After the employee is infected with malware, which they don't know of course, they're going to be accessing the company's server. They will be accessing the website and they will be accessing the server itself. Now the website has users and other records, so it would store all this data in a database that is also on the server. Meanwhile, the attacker is recording the keystrokes of the victim, and the attacker is going to use those keystrokes to access the website as well as the server. Once the attacker got access to the server, they will leverage that to access the database and do all sorts of other malicious activities. Let's see how that works. The first step in the attack is for the attacker to generate the malicious PDF file and send it to the victim and hope that the victim is going to open that file. Not only that, the attacker needs to hope that the victim does not have an antivirus or some software that will detect the file as malicious. There are a few things that the attacker can do here. First thing is social engineering. Social engineering is manipulation of people into actions of divulging information. For example, the attacker can first contact the employee through email and pretend to be a recruiter from LinkedIn, asking if they would be interested in an exciting opportunity. The victim may say yes, and the attacker can send them a PDF file with details about this position. So assuming that the victim is going to open this malicious PDF file, the next step now is to create this PDF file. I want to show you the process of creating this PDF file because it's quite interesting. As you can see, I created this malicious PDF file called evil.pdf, and the moment I drag it to my Windows 10 desktop, I get a virus and threat protection alert. That's not good. I don't want this file to create any alerts on the victim's computer. So I changed the extension of the file to .bin, and as you can see, the file can be copied without any warning and even be renamed to a PDF. Next thing, let's check a zip file. A zip file does not generate any warning either. But I don't want to send a bin file or a zip file to a victim. I want to send them a PDF. So here's what I've done. I've taken a tax document, 1099, and I'm hiding my malicious file inside this tax 1099 file. As you can see, the original text file is very small, and the tax file with the malware inside is just a little bit bigger, but still very small. Now there are two reasons that I went into the details of how I created this PDF file. The first one is to show you that attackers have a lot of challenges and obstacles that they need to overcome in order to launch a successful attack. And secondly, attackers can always find ways to go beyond and above the protections, even if there are new protections. Attackers will always find ways to circumvent those protections. So now we'll see how the attacker breaks into the victim's computer and from there into the company's server. And I'm going to switch between the attacker VM and the victim VM without interruption. Here we see the attacker launching the exploit. This starts the attacker's server. On the victim machine, the victim receives the malicious PDF file from the attacker, opens the PDF file, and as you can see, the malware starts executing and creates a link to the attacker's computer. The attacker starts a key scan that records the keystrokes on the victim's computer. The victim connects to the company's website, for example, type in their username and password. Keep in mind that the malware is now active on the victim's computer, so everything that the victim types is being recorded. For example, if the victim were to go to their online banking site, those keystrokes and passwords would be recorded as well. But what the victim is doing next is logging into their company. So they use a command called putty, which is a program for remote shell. They're typing their password, and now they're connected. On the attacker machine, the attacker is dumping all the keystrokes that they recorded, and you can see all the passwords and everything that the victim was typing. The attacker is now going to take this information and do the same, basically log into the company's server. As you can see, the attacker gained access to the company's server. Next thing that the attacker can do is log into the company's website. The attacker goes there, types the username, goes back to the keyscan dump, take the password, paste it into the browser, and log into the company's website. Now, of course, once the attacker is in the company's website, the attacker can do all sorts of things. They can post malicious links on the website, can carry many more attacks. So now that the attacker was able to access the company server, the attacker can explore the server and find all sorts of information that would allow the attacker to spread in the organization. Let's see what the attacker can do. The attacker knows that the website that's stored on the company server is a WordPress website, so they can go to the configuration file for WordPress and find all sorts of interesting things like the access to the database. As you can see here, the database username is WordPress, the database password is ABCD1234, and there is a lot of authentication keys and security keys that appear here in the configuration file. One takeaway from this is that when companies tell you that their database has been hacked, but all the passwords are encrypted, they don't tell you about all these security keys that are found in configuration files. Hackers can leverage those keys to actually figure out what your passwords are, despite the fact that the passwords are hashed or encrypted. Now the attacker is trying to log into the company's database using the WordPress username and password. As you can see, the attacker can see all the tables in the database. Look at the users table. The attacker can see all the email addresses and their hashed passwords. Now the attacker can use all the emails to send spam to the users and do other attacks on the users. The attacker can also see the environment variables. Companies typically store in the environment all sorts of secret keys. So as you can see, the attacker can see the environment as well. One of the most common attacks in 2020 is ransomware. Ransomware is when attackers break into servers of other companies and then encrypt the data that they find on these servers. The attackers then demand ransom from those companies in order to decrypt their data, hence the name ransomware. And the payment is typically done in currencies that are difficult to trace, such as cryptocurrencies. So we're going to see in this example how the attacker will use their ability to access the server to encrypt the WordPress data and demand ransom for that data. Let's see it. As you can see, the attacker logs into the company's server, going to the SQL directory, but cannot do that because he doesn't have super user permission, but he can change to a super user. And again, this is because in most companies, when they give their employees access to the servers, the access is typically as a super user. So the attacker goes to the WordPress directory and encrypts all the files. The attacker uses the zip command to create a zip file. The next thing that the attacker will do is to delete the original WordPress data. And finally, the attacker is going to add a message to the company that if they want the decryption key, they will need to pay some ransom to the attacker. Of course, this is just a fake message here, just for demonstration purposes. The attacker can also check that the attack is working, and it is. Let's see how the attack looks like on the victim's computer. The victim is going to their website, the company website, and as you can see, there is no company website. WordPress looks like it's just installing, which means that there is no data. This is how the company knows that there is a problem with their website. The last attack that we're going to see in this presentation is a denial of service attack. Denial of service attacks do not require the attacker to access or break into the company's servers. The attacker can simply interact with a company server in a way that will bring that server down. The nature of denial of service attacks is that they overwhelm the server with requests. It's kind of similar to a person who has a phone and then thousands of people are calling that phone. Eventually, some people will not be able to get hold of the person that they are calling. Same thing happens with servers. They only have a certain amount of capacity to take on calls. What you're seeing here is the attacker machine. The attacker simply visiting the company's website, and they're doing so from the command line. So there is no need to visit the company's website from the browser, and they do that using the wget command and typing the address of the website. At the top of the screen, you can see the load on the company's server. The load is currently 0 because the server is not overloaded. Now the attacker is going to amplify the attack and make the same request for the company's website 500,000 times in sequence. As you can see, the load on the server is climbing to 5.2 and then 7.8, and towards the end it comes down back to 1.9 and then 0. Keep in mind that the attacker might have a botnet, which, like we said before, is a network of computers that have been compromised and are now under the control of the attacker. The attacker can use the botnet to amplify this attack on the company server and bring the server down. Attackers do these attacks for all sorts of reasons. Sometimes it's for financial gain and sometimes for political reasons. I hope that you enjoyed this video, and I'm looking forward to creating another video where I share my tips with you on how you can protect your computer. So don't forget to click the subscribe and notify button, and see you soon.